All right. So thank you everybody for joining us today. This is Mike Rennie from Lovelytics. I'm joined by my counterpart, Amar Danthala, who will be taking us through a predictive analytics overview in Alteryx. So again, you've probably heard this before, but can't help ourselves to introduce ourselves. Lovelytics, we're a data analytics services firm based out of Washington, D.C., with another HQ up in Toronto, and we're an Ultrix Services partner. So along with being an Alteryx Services partner, we know that there are other parts of the business technology, business intelligence pipeline, right? So we're also partners with Tableau, Google, Snowflake, Mapbox, just to name a few. So if you're using and leveraging, those ancillary technologies and trying to figure out, hey, how does this all work together? That's where we come in. So as an enablement and services partner, we help with training, enablement, working on those key use cases, as well as getting your employees up to snuff, comfortable to continue running forward with these analytical tools. So a little bit about me. It says avid golfer on here. I would say, kind of a hack golfer might be a more honest term to use, but I work in the business development team here at Lovelytics. But more importantly, today we have Amar, who's our head of Ultrix Solutions. He is also a user group leader up in Toronto. He's got pretty much every certification that Ultrix offers. He's really a one-stop shop when it comes to figuring out the best way to use Ultrix for your use cases. And when we think about Ultrix in general, right, and we look to their analytic process automation platform, right, there are a lot of different component parts that make up the suite of tools that they have within their product stack. And traditionally, this is where you get started. Hey, we're blending data, we're trying to profile it and qualify data in, qualify data out, as well as we're probably sending this somewhere to visualize, or we are pushing this to some other team to use the data in another local application for another use, or potentially we're sharing data in our organization and we're packaging it up for them again in an easy to digest fashion. And I think that is kind of the classic way to think of Ultrix, and certainly how it's endeared and enabled so many organizations. We've got data, it's disparate. We need to combine it into a meaningful way so that we can serve these stakeholders within our company that have different uses based on the data that we are collecting. So I think that that's a very natural place to begin with Ultrix, and certainly to get a lot of value out of it. And what we're going to be talking a little bit about today is, all right, so what happens next as of course, we have used Ultrix, or we understand it. We have some traditional kind of data prep and blend, ETL use cases that we're looking to leverage the platform for. And what we're going to be talking a little bit more about today is specifically predictive analytics. And of course, it's never bad to kind of go and look up, all right, well, what exactly is predictive analytics? And so, as we've defined it, as we are familiar with it, it's a variety of statistical techniques, from data mining, modeling out predictive workflows, machine learning, all to analyze current and historical data, to peer into the future, to make an informed decision based on what we've collected in the past, and what we can, begin to expect the results from those predictive insights. So if we go back to that slide, really where we are focusing in on today is really, these two buckets within the overall platform. So prescriptive analytics and code-free data science. So we will certainly be getting to some use cases in a bit. And when we think about predictive analytics, again, we at, in the Ultrix community, like to think of, anyone with a question of data as somebody who can analyze it. And Ultrix makes it easy as well for, those folks who, hey, maybe I didn't get, an MS in data science, but I do have questions that I would like to use, the predictive analytics tool set from Ultrix to do, And that's where the idea of the citizen data scientist comes in. So how can we make it easy for those users who right, may not have a deep expertise in machine learning, or have that degree confirmed from a prestigious university. But certainly I want to get smarter about the way that I'm analyzing data. I want to use the data that we've already collected to make informed predictions about the future. And what we'll be talking about today and demonstrating is how Alteryx makes that very easy. One, for somebody who does have some background, and then two, for those folks like me who have got no background, how can I practically get started doing that? So we'll overhaul all of the predictive analytics capabilities that are in there. Of course, right, there is R integration, and now there is Python integration, so we can speak to that as well. And then how do I communicate what we've discovered and uncovered in our predictive analytics models? How do I, again, make that part of the overall story in your BI pipeline? And specifically, one area that we're going to be jumping into is the Ultrix Intelligence Suite. So this is an additional product that complements Alteryx Designer, and it integrates in directly with Alteryx Designer to make those drag and drop code-free predictive models available. And Amar, I think I'm going to hand it over to you just for a little bit more of a description here on the Intelligence Suite toolkit, if that's all right with you.
Yeah, my quick audio check. Do you hear me okay?
Yes, sir.
Yep. So thank you, and I hope everyone is doing well. Thank you for joining us. As Mike mentioned, today we'll be going over some, when I say some, going over one predictive analytics use case. We'll be looking at heart disease prediction. And I tried keeping it super simple and easy to digest, or at least I hope so I did. We'll be predicting heart failure for a patient based on his or her vitals information. And we'll be doing this twice, once using the Alteryx Designer and later using the newly introduced, which Mike just mentioned, the Alteryx Intelligence Suite add-on. The Intelligence Suite is a fully automated or guided step-by-step process which will help you create properly trained algorithms which are ready to deploy. The add-on, as you can see on the screen, ships with 3 different tool palettes, and they work with all the existing Alteryx Designer tools. And computer vision were very recently introduced at the Ultrix Inspire conference last week. And with 2020.2, 2021.2, the computer vision is now a part of the Alteryx Intelligence Suite. All right, Mike, I'll switch to sharing my screen.
Excellent.
All right, so if I have any new users to predictive analytics, then we usually define predictive analytics as a practice of using unbiased and reliable data to produce a predictive model or different predictive models with dependable outcomes. We follow a simple 5-step process that is crucial for a successful outcome. So as you can see on the screen, we start with data quality, and 95% of a data scientist's role in the industry is spent on just data cleaning and doing data integrity checks. So a poor quality data model will result in a poor quality predictive model. So it is often crucial to make sure that the data we are working with is clean, complete, and sensible before we proceed with our analysis. Some of the checklist items here in this category are filling in all the null values, removing outliers, doing some field encoding, and so on. Next, we have the data exploration. Here, we take a look at the data and visually analyze it to understand and decode the underlying patterns and also the relationships in the data. Understanding the relationship between different variables can steer us in the right direction and help us with nailing down our predictor variables. For example, let's say that if I'm trying to predict the future income growth of an employee, I may want to know his or her education level, the industry that they belong to, the total number of years of experience he or she may have, and so on. And exploratory analysis is often key when building predictive models. And we then move on to feature engineering. This is a data model technique which is specific to machine learning, where we try to enrich the existing data set with new attributes that we may find or pull from the existing attributes. When I say that, what I'm trying, it's often that, from your existing variables, you're trying to create new variables, which you might then feed into your model so that it can accurately predict. Next is the predictive process. We have the model building and training. So this is an obvious data science step where we liberate several machine learning models and see which one performs the best. And it usually comes down to your specific business problem or the data that you might have on hand. The last step, once your model is ready, we then move on to data validation. This is often a very important step and is often overlooked. Validation speaks for the predictive capabilities of our model and is usually key for any predictive model. In this step, we analyze the model accuracy. We also use some other metrics to maybe evaluate and understand how well the model performed. And in the end, once we are done with validation, we can then go on with predicting, like all our future data sets. I think most organizations follow this 5-step process, and they may standardize it across the different tools that may have. So here at Lovelytics, we love Ultrix, and it is a key tool in our tech stack. Most of our services for our clients are in the engineering, analytics, and reporting space. Mike, do you want to breeze through some of the services that we offer?
Sure, absolutely. So I'm just going to take control again for a second and share a little bit about our Ultrix services. Let me know when that's popping up.
Yeah, I can see it.
Perfect. And I'll be sure to share this after the fact, so I won't belabor this too much. But in terms of practically getting started with Ultrix, right, and complementing it with the other products that you invest in your BI stack, what we do is, first of all, provide training with certified trainers on our team, right? And we can do that in a number of formats, ultimately to focus on the features and use cases that are most important, as they relate to, the projects that you're working on today or for the internal use cases that you're tasked with. And, an example of that can be starting from the very beginning and doing a 1 or 2 day offering for the core concepts for Alteryx Designer as well as for Ultrix Server. And then as well, for those folks who are looking for even a more comprehensive introduction or for intermediate or advanced techniques, again, we are able to prepare trainings for your team, customized for your needs, right, in as much as a 5-day format. And of course, too, as you're looking to stand up your environment, whether you are looking to add on the desktop automation tool, or if you're looking to invest in Ultrix Server and looking to set up the licensing and necessary hardware for that, again, that's an area that we have expertise in and are more than happy to have a conversation regarding. And of course, at the end of the day, right, a lot of projects are very custom built. So if that's something that you're interested in, right, if there's a specific project that you're working on that you want to have a conversation regarding, we can certainly work with you to scope that out and provide recommendations from our point of view as to how bring that best into production. So again, this is something that I will share with you at the follow-up email. But one thing I just wanted to put front and center while we're all discussing Alteryx right now. So I'll just stop sharing and I'll let you get back to the fun stuff, Amar.
Thank you, sir. I'll quickly share my screen again. All right, so moving on, Alteryx ships with around 260 plus tools, and these are categorized into different tool palettes. Today, I'll be using 25 different tools to solve our use case. And before I go on to the demo, let me quickly give you a brief on some of the important and useful tools we'll be using today. So for the data integrity step, we can use quite a few tools that are available in the preparation tool palette. For example, I can use the browse tool, which can tell me if I have any missing data or some data that potentially could be problematic. There are other simple tools like the data cleansing tool to clean the data, the select tool to add, remove some of the fields. I can also change the data types using this field. We have the unique tool, which helps in removing any of the duplicates. I then have the data imputation tool, which can help me to fill up any of the missing data. For the exploratory analysis, where we are trying to understand our data, we can use different visual tools from the data investigation tool palette and the summarization tool palette. So pictures speak 1,000 words. We all know this. And having a simple chart helps you to understand the data a lot better than looking at a bunch of tables. So we're able to visually run custom plots on Alteryx using these tools that you see here, like histograms, violin plots, heat maps, etc. We don't even have to step outside into any other coding software like R or Python to run these plots. And we shall see some of these in action later in the demo today. And typically in tools like Python, when you're doing some exploratory data analysis, it is often so that you might need to import some packages like matplotlib, write some more piece of code just to visualize and explore your data. But here, it's just a drag drop tool. You can see the results, you can see the visualization within Ultrix itself. The third step, this is where we try and build more features into the model. So when we try to engineer, squeeze out more usefulness of the variables that we are currently in the data. And again, to do feature generation, there are many tools within Alteryx. You have a formula tool where you can create new columns. You have the regular expressions tool where, again, you can come up with new columns. You can pass the data out of a single column and turn those into new columns. And finally, you also have the join tools where sometimes if you want to do a weighted average of a variable and then bring it back and append to the original data set, you can also do so. The feature engineering has a separate tool altogether in the Alteryx Intelligence Suite add-on. We don't have to use so many tool combinations. It is all automated, which also I'll be showing you today. So this step, I think most of you might be interested, and that's the model training step. And of course, this is the most fun step because this is where you're actually running the predictive models themselves. So here you can see that we have the widest range of algorithms available, starting from basic regressions to the most complex neural networks. And the best part, once again, is you don't have to run any code to run any of these models or algorithms. Finally, validation. This again is the most important step because it's really important. I can't stress this enough to check if a model we built is performing to the best of its abilities. And again, without going too much into detail, we have a couple of tools which let us do this. And if it isn't obvious by now, the best part about using Alteryx is that you don't need to know any programming language to run any of these tools that you're seeing on the screen. They behave and perform the exact same functions that any programming language would do. And for someone like me who's comfortable with coding, I think Alteryx really makes things a lot easier. Looking at something visual versus having to read through someone else's code, I think I would prefer the former. And because the workflows are visually linked together and are often very coherent, as opposed to reading lines of code, this tool just makes everything a lot better. All right, so let's move on to hopefully the most exciting part of today's webinar, the use case. So I'm going to be talking a little bit on diagnosing heart diseases. And in case if you're wondering, can a predictive model really do that? Thanks to the field of predictive sciences, you'll be surprised. So here today, I have a really old data set, which has data from a 1989 study conducted by an organization. And their data scientist at the time was actually investigating whether the law of probability algorithm could help in diagnosing a heart disease. So basically, it was research that was ahead of its time. So the data comes from 300 patients who were undergoing angiography at the Cleveland Clinic in Ohio. This data we have includes several detailed attributes that can help predict the heart disease in a patient. And some of these attributes include age of the individual, sex, cholesterol levels, their heart rate, resting blood pressure, etc. And the objective here is to predict which patients are more likely to have a heart disease. In other words, it is a yes or a no problem. As in, yes, a patient has a heart problem, or no, the patient does not have a heart problem. For those of you who know a bit more about predictive analytics, you may know this as what we call as the classification problem, where the model can predict a yes or a no outcome. And if you're starting to think, what's the use of this when we have doctors and emergency services? I think there are some use cases where this is going to be really helpful. For example, if a hospital has a very long waiting line situation with very limited number of doctors, I think that has been the case in the past year during this pandemic. We're all aware of the situation where the doctors were always limited. So yeah, I think hospitals would want to think about ways in which they can prioritize people who are more likely to have a heart disease. And I think in most cases, hospitals usually rely on some sort of checklists to prioritize patients. But in this case, we can move beyond just a simple checklist and actually use all the data points that we have on that patient to really predict what are the circumstances of this patient. Should we prioritize him or her? And then we can move on with further screening. All right, so here is what the workflow for today looks like. Let's look at it on a high level before we actually dive in. So as you can see, I've broken it down into 4 different sections. And if you pay attention, these 4 sections kind of map to the steps that we talked about earlier. The only step that is missing here is the feature engineering, but the rest is pretty consistent with all the steps that we follow and recommend. And hopefully in a couple of minutes, you'll be see how easy it is to move from the start with the CSV file all the way to the end where you have a trained and working predictive analytics model. All right, so let me change my screen to Ultrix. And before I move ahead, any questions? I'll just pause for a couple of seconds. Cool. So yeah, here is the description of all the variables that are available in our data set. So obviously we discussed a few earlier: sex, cholesterol, resting, heart rate, etc. So we'll be using all of these to predict, what is the likelihood that a patient might develop a heart disease. So I began by obviously importing the data itself, and over here, you can see that we pull in a CSV file, .csv. I also have a delimiter, which is reading and separating out my data set. And I can then audit this data set using a browse tool. And the browse tool on a high level gives me information on all the variables in my data set. So I can see what is the mean of all the different variables, how are they distributed, etc. And more importantly, though, this tool also lets me check the quality of the data. I can actually see my data quality immediately when I look at the color associated with my column name. So Alteryx uses the traffic lights color pattern to show me the quality of the data. And this is a feature that they call as data profiling. So at a glance, I can see all my data is perfectly fine, denoted by the green color here. There are no missing values. There are no string characters with any white space in the front or at the back or at the end of the fields. And I think this is one of the most useful things in Alteryx, because I guess even in Python, you would have to literally check each column manually, or like I said earlier, you'll have to import matplotlib, write some more code, visualize it, and then assess or do the quality check. Something super simple like this is not easily available in Python. So I think this visual check helps us to know that, okay, the data we have imported is good, everything is fine. We can now move ahead and go ahead to exploratory data analysis. So next, I also usually do some high-level data cleaning using the data cleansing tool, which sits in the data preparation tool palette. But since our data is clean enough, I skipped the step and went ahead with renaming some of the fields using the formula tool. And I also did some encoding here. And encoding, again, like I mentioned earlier, is a process of converting some string objects to Booleans. So here I'm just adding a variable which is giving me yes or no. And this later on, will be inputted into the model, which we can use. So next, we move on to the exploratory data analysis. I have a couple of hypotheses that I want to check for. And this is a pretty standard practice whenever we have a prediction problem. That is, we should always explore the data, check a couple of things that we might think might be related to the outcome that we are trying to predict. So I will begin by doing the very first check. And here, what I'm trying to do is I'm trying to look at the class imbalance. The class imbalance is a check that we perform on our response variable, looking for any skew that might throw off our model. Because when you're trying to train the model to classify our patients, it is important to have a good understanding of how many of each class or how many of each outcome there are before we can tweak the model so it can predict accurately. So if I point your attention to the results window once again, we have 164 as no and 139 as yes. That is, in the entire data set, we have 139 patients who are likely to have a heart disease or who have a heart disease, and 164 patients who do not have a heart disease. So this is kind of fairly even, especially by classification standards. So I think I'm not too worried. I'll just move on, exploring the data some more. Yep. So moving on to the hypothesis tests. The first hypothesis that I have here is patients who are older are more likely to have a heart disease. In order for me to check this hypothesis, I'm using a violin plot, and this sits in the data investigation tool palette. The violin plot allows us to, look at the comparative distributions of variables that are available across our data, and looking at the excuse me, let me see if I'm able to zoom this a little bit. Okay, maybe I need to change the tool configuration itself. Okay, never mind. So what you have on your left-hand side is the age. Yeah, that is the axis that we are looking for, and bottom here is the no, and here is yes. So looking at the distribution results, we can see that the older a patient is, the more likely he or she is to be diagnosed with a heart disease. And, that obviously makes sense because, medically speaking, that age is a good predictor for telling if somebody is likely to pick up a disease. And I think we are able to replicate that understanding just by looking at the data itself. We can see that there's a huge bump here over at around, I think it's a 60 or 60 or 70. In contrast to those who were not diagnosed with a heart disease, where the distribution is a little flatter, or we can say that it's a bit more even. So, we can use the violin plot when we need to see some useful information about the data and how it is distributed. And when, especially with respect to the variable that we want to predict, the violin plot can help us really understand the underlying patterns in the data, and kind of, make us take an informed decision as to if we need to use this variable as a predictor or not. All right, so on to my second hypothesis. Patients with a higher resting blood pressure have a lower maximum heart rate achieved. So here I'm using a scatter plot, and heart rate and resting blood pressure are the two attributes in the data set that I'm trying to understand if there is any relationship between, so I can understand my data better. So if you look at the scatter plot, it just looks like a random cluster of points, which tells me that there is no relationship between the two variables. I could also conclude that by looking at the solid line here, and that is the line that we would be produced if you ran a linear regression on this cluster of points. And you can see here these two arms or the box plots. They tell me that if I change the value of my resting blood pressure, the value of the maximum heart rate achieved doesn't actually change that line all that much. If there was any relationship, then this solid line would be skewed towards the upper or the lower section of the scatter plot. Hence, I think I can also strike out my second hypothesis and move on to my third, which is most patients in this data set might have a high serum cholesterol level. As you all know, cholesterol levels in heart disease are very well correlated with each other. So I don't have to check for a relationship like a scatter plot, but I would want to know how is the age group distributed like. So if you look at the results on the left-hand side, we can see that, interestingly enough, we have a lot of people within the 200 to 300 range. And we can also see that all the way out at 600, we have someone or a couple of people. So these are the ones who we might call as the outliers. So these kind of situations might perhaps suggest that, we do have an outlier, and to identify something like this, a histogram actually is a best chart that is available right now. And it's often important to also identify outliers in the data, because outliers, can happen, sometimes when there is manual data corrections, and using a chart like histogram, you can easily identify and rectify such data issues that might happen, when you're preparing a data set perhaps, or, you're only taking a subset of the data. You have to do some manipulations or modifications on it just to run some preliminary analysis. So when things like that happen, often using a histogram to check for outliers. There are a couple of other ways to do it, but here, for the sake of simplicity, I'm sticking to a histogram. All right, so that's the exploratory data analysis stage. And I hope this brief examples has given you a good idea on how you can use Alteryx to understand your data. I skipped the feature generation, and I'm directly moving on to the fun and interesting step, which is the model training. And again, for the sake of simplicity, I didn't do feature engineering, and this data set didn't also require feature engineering. So I directly went into, running my models. I'll just pause for a second and sip some water. Any questions so far? Is the pace okay? Do you want me to slow down? Do you want me to rush? All right, moving on. So up next, I am using these three tools. And with the combination of these three tools, what I'm trying to do is something called as sampling my data. And for anyone who is hearing this term for the very first time, we do sampling on our data so we can train the model accurately. And sampling is a process where we ensure our training set, that is the data the model is learning from, and the test set, that is the data we use to evaluate the model, have equal proportions of yeses and nos. And this is our way of ensuring that the model is accurately getting a good representation of the reality. So the sampling is also done in a couple of different combinations. We do a 60-40, 70-30, 80-20 split, where 60% of the data is used for training and 40 for validation, 70 for training, 30 for validation, and so on. So here, again, I have one or two ways to do the sampling. Here I'm using a randomized ID, and then I'm just joining back it on itself so that, I'm choosing to do it this way, but you can simply use the create samples tool and then do a 70-30 split. I've done that in my second example, but again, this is one other way to do it. All right, from here, we are now actually we move on to using the machine learning models. Here, I'm using 3 different machine learning models. And it's kind of a standard practice in the industry to run a couple of models together before we actually finalize on a single model, because we don't actually know which one is going to perform the best. And it is kind of why it's important that we run multiple models. And in the end, whichever performs the best, we can use that model and deploy that model onto production. So one of the best things about running these models on Alteryx is you get detailed reports as an output from the model. The first model I have here under the classification class is the Logistic Regression. And if you look at the tool configuration, I just select my target variable and my predictor variable, and Alteryx takes care of the rest. So in the output, I can clearly see which variables were statistically significant, what kind of effect do they have on the marginal probabilities. And with that, I would say that interpreting a model output is really important when you want to understand what exactly is going on the hood, because you don't know, you're not able to see the underlying algorithm. So it is important that you get and predict these results right. The second model I'm using is a Dacian tree. And a Dacian tree is a graphical representation of all the possible outcomes that we have for a Dacian based on the different conditions that we might have. For those of you familiar with Dacian trees, the output in Alteryx actually gives a leaf summary. We also have a cool visual representation, but looks like the plots are not loading here. But generally, you get to see a really cool node split. Let me see if I can. Anyways, let's move on. The final model for today is support vector machine. This is a traditional model that not many people use, but I really wanted to show you is this cool looking classification plots, super easy to read. And these plots essentially demark and keep regions in an n-dimensional space. Cutting out the technical jargon, what a classification plot tells you is if a point is falling within a space of a certain range, then it would classify it as a yes. And if it falls outside, then it would classify it as a no. And Alteryx has this visual representation and in the output of the support vector machine model. In any other platform out there, you just need to import libraries and manually chart out, like you need to configure your axes, colors, etc., and then chart it out. So I think it's really cool that we have to put in zero effort to look at the classification plots. All right, so we're almost at the end. So in the last 15 minutes, just like that, we were able to build a predictive model. I don't know, in a couple of steps and barely using 20 different tools, we're able to, predict a model and then train a model and then predict the outcome from that trained model. So in this final step, we validate our models using the model comparison tool in Alteryx. And finally, we predict our outcomes using the scoring tool. And this is the validation phase where we basically evaluate the model is doing and make sure that the predictive accuracy of the model is likely to carry over to our future data sets. And if you look at the output of the model comparison tool, it gives us the accuracy scores of all the different models that we used. So in this case, turns out that the logistic regression is the model with the best accuracy. I mean, there's close differences, but clearly you can see the almost 10% difference between the logistic regression and the Bayesian tree. All right, so this again, I just wanted to add it in here because once you're done predicting using the scoring tool, you're pretty much done. You can then save that output to a file, and then you can use that to do further analysis. But you can also manually do a check on the accuracy of your models. So when I share this workflow, just take a look at these 3 steps. If you don't want to use the model comparison tool, this is one other way of checking the accuracy of your models. And if you're wondering, all of these are connected, but I just made the connection wireless just so that it's neat and tidy. And if you want to know how to make a connection wireless in Ultrix, just click on it and select Make Connection Wireless. So wrapping up, we have seen a 5-stage process to predictive analytics using a data set, and we built a couple of models. And throughout this process, I knew what I was doing, and I have a data science background, so it was easy for me to use all these tools. And I apologize if I was flying through all of this because it's a lot of content to cover in 45 minutes. But what I want to say is, what if you're someone who is just getting started in this field, or if you are completely new to data science? I can understand that all of this can be a little intimidating or overwhelming at first. And I believe Alteryx is solving for this problem by enabling all their customers with the power of Alteryx Intelligence Suite. And the Intelligence Suite is a fully automated end-to-end machine learning add-on that does all the predictive work for you. You don't need any predictive knowledge to use this add-on. And the add-on offers something what they call as assistive modeling, where Alteryx provides you step-by-step assistance on which model to use, or it can also straight up give you a final recommendation. Before we go on with the demo, I want to say that this is going to be a brief and quick demo on what this add-on can do. I will not be going over any of the text mining or computer vision tools, but I have plans to do a separate webinar on them in the future, so keep an eye out for them. And when you purchase this add-on, you get 3 new tool palettes, which I've shown you earlier: machine learning, text mining, and somewhere down here, the computer vision. So I think the add-on all in all gives you 25 different tools again. So 260 tools in Alteryx plus 25. So you have almost close to 290 tools in Ultrix. All right. So with the Intelligence Suite add-on, here is what the process looks like. We are still going to follow the 5-step process, but instead of us doing the work, Ultrix does all the heavy lifting. So before we let Alteryx take over, let's import the data, create a sample set that is 70%. I'm doing a 70-30 split where this is my training set and this is my test set. And I'm using this 70% so that Alteryx can use that 70% and train the model. But before I go further, let me quickly do a data health check. So we have a tool called data health for it. And if I look at the results, it kind of gives me a chart which tells me what is the quality of my data. And also we have some recommendations on each of the columns. It kind of gives you a recommended action on what you can do on that field so that it can be a little better. And again, once again, I do this because I can't stress this enough. In data science, the data integrity of your data quality of your data is a lot more important. Once you know that we have good quality data, we can proceed with any sort of predictive analytics that we may please. All right. Next, I'm using a feature types tool where the tool itself auto assigns what it thinks is the best variable type. So in this case, sometimes it could be numerical, sometimes it could be categorical. I'm leaving all that headache to Alteryx so that it can decide what to do or how to arrange these variables. So this is the assisted modeling tool, and let me quickly run this so you can see what assisted modeling in Alteryx looks like. I'll click on Start Assisted Modeling. Start building. So the very first thing that Alteryx would prompt me to do is to pick my target variable. I know in this case it is diagnosis, and Alteryx was able to recognize that this is a classification problem, and hence it has given me this classification model or classification step to run with. Dialog box just confirming if I want to proceed. I hit continue. And then here is where the step-to-step assistance that I was talking about comes in. I can also check automatic, where I won't see any of the steps, but I'll just get a recommendation saying that, hey, this is the model that you have to use. Please proceed. So for now, I'll just select step by step and click next. Again, Alteryx is doing all the work. It has decided what is the numeric types or the data types of each of these variables should be. Let me click next. If there are any data cleaning that Alteryx thinks is necessary, then Alteryx is doing that for me. And here it is replacing the missing values. It is imputing with the median of that particular field. Hit next. And then finally, it is selecting all the predictive variables that it thinks are necessary for building a model. Again, here, if there's any variables that it thinks are useless, it'll just throw them out. It'll just show you a message as to why it rejected it. I can hit next. I can select. It has, as of today, you have 4 different algorithms. With every product iteration, Alteryx keeps adding new algorithms. But if you click, you can see what are the pros and cons of each model, what are the different use cases that these models can be used for, etc. And I can just hit run selected algorithms. So once the analysis is done, Alteryx kind of presents us with the ROC curve. And for those of you who don't know, ROC is a graph. It shows the performance of a classification model at all classification thresholds. And as you can see here, the curve has two parameters, true positive rate and a false positive rate. True positive is when the outcome where the model correctly predicts the positive class. And a false positive is an outcome where the model incorrectly predicts the positive. And the positive here is the heart disease of a patient. So for every two false predictions, there are 46 correct predictions. That is what this chart is trying to tell you. And as you can see from the chart, except for my Dacian tree, all the other algorithms are fairly accurate. And Ultrix recommendation here is to use the logistic regression, which has 84% accuracy. So now that I know which model to use, I can just X out this dialog box and I can go ahead with the next steps. Once I'm done with assisted modeling, I know that this data could use some cleaning. So I'll just use the transformation tools. And again, I'm not doing anything here. Everything is automated. The first time I'll ask it to set the data types. The second time around, I'm asking it to clean up any missing values, and it decides what is the best action to do. And you can also change that. You can manually intervene and change if you want to replace it with the mode, if you want to drop that attribute altogether. Finally, I'm doing one-hot encoding. Again, I spoke briefly about this. Encoding is a process of converting categorical variables into numericals. Some of you might also know this as creating dummy variables. And the reason we do this is many machine learning algorithms cannot work with categorical data directly. So the categories must be converted into numbers. Once again, Alteryx is doing this for us. And finally, since we know that we have to use logistic regression, I use the classification tool. Again, remember I was mentioning that we have an inbuilt tool for feature encoding, and this is this one right here. I'll just drag the classification tool. Again, no configuration, everything is automated. I just select what is the model that I want. I leave everything as is. And then the training happens with the fit tool. Again, no configuration. Even the predict tool has no configuration, but it just gives me, as soon as I run this, just like that, I have the predictions. Again, I am connecting my test set to the predict tool, and I'm connecting my model output to the M of the predict tool, to the M input of my predict tool. And here we have our predictions with all the accuracy rates. So that is Alteryx Intelligence Suite. It pretty much takes away all the work, and the tool is doing everything on its own. And yeah, so all starting from steps 2 to step 5, all of this was offloaded and Alteryx was doing all the work for us. Again, this is not meant to replace the data scientists, but this is meant to enable the upcoming data scientists or citizen data scientists to get into the field of data science and learn and take out their apprehensions from the field of data science. So Mike will also be sharing in terms of the use case, in terms of demo. That is all I have for today. And Mike will follow up with more information on Intelligence Suite, the workflows that we used for today's presentation, the deck, and all the services that we offer. With that, we have 4 minutes. I know we are short on time, and I'll open up for questions. Feel free to drop off if you don't have any questions. Mike, this is being recorded, right?
That's right. So we'll be making the recording available in follow-up with all the other resources that Amar was mentioning. So this will be one, we'll give you the Zoom link, and then this will later be uploaded to our YouTube channel. So you'll be able to find it, replay it, share it as needed in the future. And then of course, too, if you have any questions that come up later today, or if you're looking to test out the Intelligence Suite add-on, just drop us a line, let us know how we can help. And two, right, if you just have questions that come up later on today that maybe you forgot to ask or didn't think to ask on today's call, don't hesitate to reach out to us either. But very much appreciate everyone attending today. We will be following up with the recording and everything else mentioned, and hope to see you again soon on future presentations. So thanks so much for your time, everybody.